Hey everyone, welcome back to Life is Learning. Today, we're diving deep into a crucial component of the 8085 microprocessor, the flag register. If you're studying computer engineering or simply want to understand how microprocessors work, this video is for you. By the end, you'll know everything you need to about the flag register and its importance in the 8085 microprocessor. So let's get started. Let's begin by understanding what a flag register is and why it's important. The flag register in the 8085 microprocessor is an 8-bit register that stores the status flags. These flags reflect the outcomes of arithmetic and logical operations performed by the ALU, or arithmetic logic unit. The microprocessor uses these flags to make decisions based on the results of these operations. First, let's draw an 8-bit box on the board. This represents our flag register. In the 8085, not all 8 bits are used. Only 5 of them are active, and these are the flags that indicate different conditions. Starting from the left, the first flag we encounter is the sign flag. This is the 7th bit, and it's labeled S. The sign flag is set to 1 if the result of an operation is negative. In binary, a negative number is indicated by the most significant bit being 1. Next, we have the 0 flag, represented by the 6th bit, labeled Z. This flag is set to 1 when the result of an operation is 0. It's especially useful for checking conditions like equality. The 4th bit is the auxiliary carry flag, or AC. This flag is set to 1 if there's a carryout from the lower nibble, the lower 4 bits, to the upper nibble during operations like addition. It's primarily used for binary coded decimal, or BCD operations. Moving on, we have the parity flag, labeled P. This is the 2nd bit. The parity flag is set to 1 if the result has an even number of 1s, indicating even parity. Finally, on the far right, we have the carry flag, labeled CY. This is the 0th bit of the register. The carry flag is set to 1 if there's a carryout from the most significant bit during an operation, or if there's a borrow in subtraction. This flag is crucial for multi-byte arithmetic. So this is the complete structure of the flag register in the 8085 microprocessor. To recap, the active flags are sign, 0, auxiliary carry, parity, and carry. Each of these flags plays a vital role in determining the outcome of operations and helps the microprocessor make decisions accordingly. Let's quickly look at an example of how these flags are used. Suppose we perform an addition of 2 numbers and the result is 0. The 0 flag will be set to 1, and if there's a carryout from the most significant bit, the carry flag will also be set. The microprocessor can then check these flags to determine its next action, like branching to a different part of the code. And that's a wrap on the 8085 flag register. Understanding these flags is crucial for anyone studying microprocessors, as they directly impact the flow of programs. If you found this video helpful, please give it a thumbs up, share it with your friends, and subscribe to Life is Learning for more educational content. Also, don't forget to hit the bell icon to stay updated on our latest videos. If you have any questions, feel free to drop them in the comments below. Thanks for watching, and I'll see you in the next video.